Hello everyone. So today we will be solving some questions, some selected questions from January 2024 Chemistry IAL Unit 1. Firstly, this question number 1. It says the first ionization energies of four successive elements in the periodic table. These are shown here. Now these are the four successive elements. Now see, since these are four successive elements, so what you should do is, before solving any questions here, you can figure out the group numbers. Since these are successive elements, usually the highest one is always group number 8, because in any period the the element with the highest first ionization energy is the element in group number 8. So since these are successive elements, if this one is group number 8, then the one before it, which is P, should be group number 7, and the one which is after group 8, which is R should be group number 1, and the next group should be group number 2. So that's how we figure out the group numbers, and then you answer the question. So question number A says, which element has atoms with a full outer shell of electrons? Now the element that is full outer shell of electrons is basically, they're talking about group 8 element. So your answer to question number A must be Q, because Q is in group 8, right? Since it has the highest first ionization energy, it must be element Q. Then B says, which element could be in a gaseous covalent compound with the formula HX? Now could be X with the formula HX. So X must be a group 7 element, right? From the formula we can clearly understand HX. Basically it might be HCl or HF or HBr, right? Because hydrogen halides have this kind of formula. So this must be group 7, and the group 7 is the element P. So the answer to question number B must be A, right? All right. And then we have question number C. It says, which element could be Y in an ionic compound with the formula YF2? So it's an ionic compound with fluorine as the anion and with Y as the cation, and this element Y has a charge of +2, because 2 fluorine atoms has a charge of -2. So the cation Y must have a charge of +2, right? So this element must be a group number 2 element. So the group number 2 is the element S. So the answer to question number C will be element S. All right. And then it says, which element has atoms with the largest atomic radius? The one with the largest atomic radius, now if you look here, now as we are moving along the period from P to Q, P is in group 7, Q is in group 8. As you move along the period, the ionic radius decreases. So Q must be smaller than P, right? Now from Q, we move to the next group, right? So Q is in group 8, now R is in group 1. Since these are successive elements, so next to Q is R is in group number 1. So as you go down, the radius increases, right? And from R to S, since R and S are in the same period, when you move from R to S, the atomic radius also decreases, because along the period the radius decreases, right? So R is below Q, because for example, if Q is in period number 2, R is in period number 3, right? So period number 3 elements will have a higher atomic radius than period number 2 elements, right? Because we are moving down from one period to the other, the atomic radius increases. And from R to S, since both of them are in the same period, S will have a smaller atomic radius than R. So R will have the largest atomic radius. So your answer will be C. Okay, we move on to the next question. The next question, it says which pair of atomic numbers are those of elements that are in different blocks of the periodic table. Now if you look at option A, it says 5 and 9. Now atomic number 5 is boron and atomic number 9 is fluorine. Now both fluorine and boron are in the same period. Both of them are actually in the P block of the periodic table. So 5 is boron and 9 is fluorine, right? So they are in P block. Both of them are in P block of the periodic table. Yeah. Now the atomic number 10 is neon and 16 is sulfur. Now both of them are also in P block, right? Now if you look at 13, atomic number 13 is aluminium and atomic number 18 is argon. Both are in the P block of the periodic table. And if you look at option number D, 16 is sulfur, 20 is calcium. Sulfur is in the P block and calcium is in the S block. So the answer to question number 4 must be D. All right. Okay. Now we move on to the next question. The next question you wanted me to solve was the concentration of sulfur dioxide, was number 13. The concentration of sulfur dioxide in a sample of polluted air is 0.4 ppm. What is the percentage of sulfur dioxide molecules in this polluted air? Now if you want to convert ppm into percentage, it's a very easy way to convert ppm into percentage. So you remember we studied in our class that ppm can be calculated from percentage. ppm equals percentage multiplied by 10 to the power 4. That is, if you multiply 10 to the power 4 or 10,000 by the percentage, it turns into ppm, right? So what you can do is you can find the percentage by dividing the ppm by 10 to the power 4, right? You divide by 10,000, so this would be ppm is 0.4 ppm divided by 10 to the power 4. So 0.4 divided by 10,000 will give you 0. Sorry, there's not much space here. This would give you 0.00004%. So your answer would be C. C is the correct answer. Oh, you're right. Which mixture, the next question is question number 16, which mixture could be formed when a single molecule of C12H16 is cracked? It's a very easy question. What you do here, you add all these formulas together and check whether you get C12H26 or not. For example, butene. Butene has the formula C4H8. You add a pentane. Pentane is C5H12. You have propene. Propene is C3H6. Now if you add them, the total number of carbon atom sums up to be 12, but the total number of hydrogen sums up to be, this is 20, that is also 16. Yeah. Wow. That was 26. Oh, A is the answer. Oh, wow. A is the answer, yeah. So if you add all these three, you get this as the answer, because 12 plus 18, 12 plus 8 is 20, plus 6 is 26, right? Yeah, so A can be the answer. Let's also check B. B, C and D will definitely be wrong if you check B. B is hexane. Now hexane is C6H14, butene is C4H8, ethane is C2H6. If you add them, the total number of carbon is again 12, but the number of hydrogen is this time is 28. So therefore B can't be the answer, because you have more number of hydrogen atoms here, because we are looking for C12H26. Now this sums up to be C12H28. So B cannot be the answer. Let us look at option C. Option C, it says non-N. Non-N is C9H20, and then you have ethene. Ethene is C2H4. Now if you add them, this sums up to be C11. It's already C11, so this cannot be the answer, right? It is C11H24. So therefore non-N and ethene together, they have only 11 carbon atoms. We are looking for 12 carbon atoms. So C will not be the answer. Then we have propene and decane. So it's quite evident that this will not be the answer, because propene is C3H6 and decane is C10H22. So it sums up to 13 carbon atoms, and there are 28 hydrogen atoms. So therefore this is also not the answer. So the correct answer is A. A is the correct answer. Alright. Okay, thank you. Okay, now we are moving to question number 22. It says to calculate the molar mass of the unknown gas. Now you have been given the density of the gas, you have been given the temperature and the pressure, and they have already given you the formula PV equals to nRT, right? So using this formula, you'll be able to find the number of moles of the gas. If you can find the number of moles, you can easily find the molar mass of the unknown gas. So we use the formula PV equals to nRT, right? So the pressure that is given here is 101,000 pascals multiplied by the volume. Now you are not given the volume. The volume is not here, right? But we are given the density. Now what is the density? The density is 0.656 grams per dm cube. It means 1 dm cube has a mass of 0.656 grams. So when we look at the density, we see that 1 dm cube has a mass of 0.656 grams. So what we can easily do is we can take 1 dm cube as the volume, 1 cubic decimeter as the volume. And if you take 1 cubic decimeter as the volume, we can use this as the mass when finding the molar mass, right? Because we know the density. So if you take 1 cubic decimeter volume of the unknown gas, the mass used should be 0.656 grams. So we have to. So what we do is we put this volume here in PV equals to nRT. Now this volume is in cubic decimeters. You have to convert this cubic decimeter into cubic meters. So 1 cubic decimeters will be equal to 10 to the power minus 3 cubic meters. So here the volume would be 1 multiplied by 10 to the power minus 3. So this has the unit. This has the unit in pascals. Volume has the unit in cubic meters. This would be equal to N is the number of moles multiplied by R is always given in the question 8.31 multiplied by the temperature. Now the temperature must be in Kelvin. Now the temperature given is 20 degrees Celsius. You have to convert the temperature. So this would be 273 plus 20. Now if you calculate the number of moles, the number of moles is found to be 0.04148. This would be the number of moles of this unknown gas. Now using the mass, since we have taken 1 dm cube, 1 cubic decimeter as the volume, the mass of the substance must be taken as 0.656. So you know the mass of the substance, you know the mass of the, you know the moles of the substance of the gas, you know the mass of the gas, you know the moles of the gas. So therefore you can easily find the molar mass of the gas. So molar mass will be 0.656 divided by 0.04148. And if you calculate the molar mass comes out to be 15.81. And if you round it up, you can write 15.8. You can also round it up to 16 grams per mole. So since the question doesn't ask about the number of significant figures, what you can do is you can always round up to any decimal place if not asked in the question. Not really decimal place. You can round up to any significant figure, as it's not because the question doesn't ask for the number of significant figures, a specific number of significant figure. So what you can do is you can round it up to any number of significant figures, except one significant figure. 1 SF is never accepted in the exam, never. So if nothing is said in the question about the number of significant figures, what you basically do is you can round it up to any SF except 1 SF. 1 SF will always be given wrong. Now the next question, it says you are to give the name or formula of the unknown gas using your answer to A. It says the unknown gas is hydrocarbon. So what you can do is you can start with the simplest hydrocarbon. Now which is the simplest hydrocarbon? The simplest hydrocarbon is methane, right? So you start with methane. You can start with alkanes, right? If it's not an alkane, you can move on to alkene and so on. But if you start with the simplest hydrocarbon, which is an alkane, which is methane, which is CH4. Now methane, CH4, also has the molar mass of 16 grams per mole. Methane has the molar mass of 16 grams per mole. So therefore, the answer to this question would be methane, will be CH4. Or you can write in words as well, that's fine. Because they ask for name or formula.